How's it going, everyone? My name is Andrew, and from the title of the talk, winter is coming, so prepare for your next big incident with open source tools. Kind of gives you a general idea of what we'll be talking about. So, wondering who here is a fan of Game of Thrones? Anyone? You? Okay, well, fortunately this talk is nothing about Game of Thrones at all, so this is just a point to get you here. But either way, that's kind of, in general, what we'll be talking about, so.
All right, so my name is Abel Morales, and we don't want to end up like Tyrion. So Andrew and I are actually both actively employed, so we'd like to remain actively employed. So we want to make sure we don't end up like Tyrion and get in trouble. So anything that we give you, any information we give you, it's actually ours. It doesn't represent our employers, our subsidiaries, or their subsidiaries, or their employees. So we obtained this legal disclaimer from our professional legal team or professional legal repository, which is Google, and I hope this is enough to cover us.
And so who we are, I'm Andrew Donahoe. I'm an incident response analyst at Verizon. I'm the internal team, not the external team. And so, I enjoy scripting, anything really DFIR related, and, I've got about 4 years of experience.
So again, my name is Abel Morales. I'm currently a principal incident handler at Verizon. Just out of curiosity, does everyone here work on the corporate side for a company, actually? Okay, so there's probably some vendors in here as well. So we both work for the corporate side. I enjoy threat hunting, digital forensics, and incident response. Most importantly, I think in our role, and what I enjoy most is really understanding the root causes of what happened in an incident and understanding it at a deep technical level. I currently hold a few industry certifications. All right, CISSP, GCIH, and MCSA, which according to every LinkedIn recruiter, that makes me a subject matter expert in all things cyber. So, thank you. So just a quick overview of the agenda. Today we're going to talk about some of the incident response challenges that we encounter today within our current roles. We have several years of combined experience within IR. A lot of things that we run into on a day-to-day basis. We'll also talk about the difference between open source and commercial tools. I don't think there's just one size fits all for everyone, so we'll talk a little bit about that. And then we have several tools that we want to share with you guys today and go over that are open source that I think every organization can actually leverage in some capacity. And then we'll just wrap up with some key takeaways, and if we have time, we'll take some questions. So incident response challenges. So after doing incident response for quite some time, one of the issues that we typically run into is that we have flexibility. We don't have a lot of flexibility in the tools that we use, right? So commercial tools, until recently, have been typically closed box. So it doesn't give you a lot of ability to customize and kind of cater it to your own environment. Another big issue we have in just working large incidents, medium or even small, you kind of run into this rabbit hole where you're just there, hands on keyboard, and you're constantly searching and pivoting, but it kind of makes it difficult to have a methodical approach in the way you do your analysis and actually pivoting and making sure that you have good record keeping. So that's the next bullet, right? Making sure you have a good record keeping and are able to record the queries that you actually used to come up with your conclusion of that analysis. So if anyone's here ever dealt with like law enforcement or anything of that sort, these things are pretty important in case that some incident ends up going to like court or anything like that. Another primary issue that we have is being able to query endpoints at scale. So I think the last talk was about logging. So, on all things, all network devices, all endpoints that you have today, even if you were to log all of that data, there's always going to be some type of data that you don't have, that you're not able to go back and retrospectively search. So an example I can think of on top of my head is the certificate of a serial number. So typically, if a cert gets installed, if malware installs a cert on your box, you guys currently have the ability to search for that certificate serial number within your environment at scale and figure out whether or not that certificate exists, and seeing as using that as an indicator of compromise to search through your environment. I would say most organizations don't have that. And I think it's an important capability that every organization should have in being able to query for whatever piece of information you need. And I think for some of the people here that do work on the corporate side, I think this can resonate a lot with you guys, is that there's insufficient support from executive management because they never think an incident is going to happen to them. So, previous experiences in my career is typically let's focus on the compliance and audits and let's make sure that we pass those, and let's never prepare for an actual incident. So those active investments in the people, process, and technology never really happen. So open source versus commercial, I think we all have some base knowledge of the difference, right? One is primarily focused on the vendor. The other one is primarily focused on community contributions. Primary benefit of open source software is that the source code is available. So you have the ability to go back in there and see if there's anything that will cause any type of suspicion, right? It also kind of addresses the inability of a lot of these commercial tools to integrate it and customize it to your organization because it's open source and you can actually do a lot of different developments that caters to your organization. And then that kind of leads into my next advantage, which is integrations with other tools. So unfortunately, there are some disadvantages, kind of like with anything, right? The primary disadvantage is there's no guaranteed of continued development, so there's no promise that that community is going to continue developing that software and kind of enhancing it, right? And there's also no SLAs tied to that for support issues. So if you're an organization that has high availability or you're dependent on high availability, you probably may not want to do open source depending on what the specific use case is, right? I don't think one size fits all. You may want to cater a little bit more to the commercial side, where some of the advantages there is a little bit of the opposite. You can actually hold the vendor responsible for some outages, any actual issues that you encounter, because you have a contract that you sign that has some type of SLA tied to it. Also, the training options that vendors typically have, they're pretty good. They have a lot of flexibility as far as doing on-site training, good documentation, et cetera, and they also have an SLA tied for support issues. I will say, though, that in my experience, what I've seen with commercial support is you'll run into cases where you kind of start at a tier 1, right? And then you start at a tier 2, and then 4 weeks later, you're finally talking to someone at tier 3. Versus if you go through the community side, you'll get a response probably within the same day from someone that's actually pretty competent. So not sure if anyone's had that frustration, but I definitely have. Some of the disadvantages, again, kind of tying back into whether or not you guys have the right executive management support, the right investments, is that if you don't have it, then it's going to be very expensive to get a commercial tool. It's going to be very hard for you to do that at your organization. There's also lack of transparency of the code. So unlike open source, you can see the code. With commercial, you can't. And lastly, this is actually one that really bugs me personally, but feature updates are really dependent on what the vendor, if that vendor can actually capitalize on it. So if the vendor is only receiving that specific feature request from one particular customer, and they have 200 customers, they're really not going to focus those efforts and on your specific use case, right? There's a lot of times I've asked vendors, hey, I want this, where they're like, well, that's not really what we're trying to do right now because no one's really asking for it. So that's pretty frustrating. That's one of the disadvantages that we have to kind of deal with in dealing with commercial. So wanted to talk to you guys just kind of the open source tool stack. Is anyone here familiar with Elk, or are we all Splunk users here? All right, a few people with Elk, okay. So Elk Stack is essentially an open source log aggregator, and it indexes data, organizes the data, and allows you to perform full text searches. So if anyone here is familiar with like Splunk or any other type of SIM, somewhat sort of like that, right? It allows you to do some data visualization. For anyone that's not technical in this room, it's essentially in the context of logs, it's a Google search for your environment, right? So one of the things that Elk provides is beats. I call it Beats by Elk because I have a set of different tools that you can actually deploy. So Packet Beat, anyone here familiar with Packet Beat? Cool. So Packet Beat is essentially an endpoint agent that captures the network traffic. You can forward that network traffic over to Elk, and then you can search. So it's kind of like the next best thing to having a full packet sniffer on the network. We also have Winlog Beat. So winlog beat is essentially another agent that would go on an endpoint, and what that does, it queries the Windows event logs on that endpoint. And you can start shipping different log sources within Windows event logs, such as system, application, security, SystemOn. So just a question out there, see if someone can answer it. So for like the system, if it would, does anyone have any idea what I would probably want to ship from the system log source?
Security logs.
So system, that's the security log source. So anyone interested in maybe 7045? The service has been recently installed, right? How about from the security event logs, what's something that would be of interest?
4771.
Okay, and can you tell us what 4771 is?
Creation of a VA account.
Okay. How about a 4624? So successful logons, right? Why would I be interested in successful logons? Anyone? So the 4624 provides some really good information, such as like logon types. And as incident responders, as we get familiar with these logs definitely mean something. So if you have an insider within your network that has primarily been using, let's say, RDP as the method of moving laterally within the environment with a specific account, you can start filtering on that specific event code using 4624 and then a log type 10, right? And having this data forwarded into a central log aggregator makes your job a lot easier than having to go back individually and start trying to figure out which box did this actually happen, right? What is really my scope? The purpose of having a log aggregator is also retention. So depending on what your organization requires, maybe a 1-year hot storage and 2 years of cold storage, whatever that use case may be, it's really important to have those logs to be able to go back, right? If you have I've seen certain servers that have like a 30-minute rotation, so they don't log very many files on there. And the primary issue is that if you have an incident that you're trying to go back, 6 months, well, 30 minutes of logs are really not going to help you. Anyone familiar with SystemOn here? Okay. So SystemOn is a free Windows system service and driver provided by Microsoft. It's part of the Sys internal suite. And I'm a fan of SystemOn, right? It records a lot of important information, command lines. So whether it's command prompt or PowerShell, it records process creation and termination, the image file hash. So any binary that executes on your system, then it'll record that hash. So if a DLL exe, it'll record that hash MD5 or SHA-256, depending on how you configure it. Also records network connections, so IP addresses, ports, and host names. So I don't know if Gartner's here, but we would like to introduce a new type of security tool, the next-gen PMED, which is a poor man's endpoint detection tool. And we didn't put the EDR because it has no response capabilities, but it does have detection tools. And that's what essentially an EDR is, right? An EDR is essentially having SystemOn on the box and providing you with some verbose logging. So I'm going to go ahead and pull up Elk. All right, cool. So we're just going to go over here. So Kavana is essentially the interface, the front-end interface for Elk. And it'll essentially let you just search whatever indexes you want. So in this case, what I've done is I've selected the winlog beat index. And what that does, it's essentially looking for all those log sources that I just mentioned, the application, service, security, and SystemOn. So one of the things that I would look for if I'm a threat hunter coming into a brand new environment is PowerShell invoke, right? Pretty simple. So let me scroll down here. So as I see, there's some interesting stuff here that's happened that I'm able to have some quick visibility into, right? So we start seeing who am I under WMI. Anyone know why it would be important for an attacker to run who am I? Yep, here we go. Use that for a drink. All right, so then we have some other interesting information, right? So we have the querying of enterprise admins, the querying of domain admins. It's a real simple and easy, effective way to start doing some type of threat hunting within your organization. From an incident response perspective, because ELK is open source, you are going to pay for it in storage, you are going to pay for it in systems, you are going to have the right skill set to make sure that you can actually operationalize it. So I think I'm pretty big on that, is if your organization has very skilled security engineers with some app development experience or scripting experience, open source can be very beneficial in automation, integration, and be more cost effective for your organization. Unless anyone here likes to pay, an exorbitant amount of money every year for their license. So this is pretty simple. You can start querying the logs. You can look at different commands and just do some simple threat hunting within ELK. Now to go back here, I want to go into packet beat, the packet beat index, and I'm going to remove this. So this is all of the data that we've been able to generate over the last few hours. So we've been working on this today as well. And if we look here through like beat host name, I can see all the different hosts that I have feeding information into here. So one of the things I did prior to come in here is, let me just show you, if I was an incident responder and I know that there's a specific C2 that is related to the incident that I'm currently working on, one of the first things I'm going to do is I'm going to start looking at my entire log source and try to figure out whether or not I've had any evidence that a system's reached out to it. So I went to virus total on one of these boxes, and here we have Lannister 2. So this traffic originated from Lannister 2. So this is kind of the next best thing to like a deep packet inspection tool. In here we can also see some additional information such as the ciphers used. We can also see the serial number, the certificate authority that issued it. So this is actually pretty important if you are an active threat hunter or if you're just doing general incident response and your specific incident requires you to have access to the network in this way. All right, so I'm going to hand it off to Andrew to just talk us through the next set of tools.
So who here has heard of OS Query? Awesome. Yeah, so basically what it is kind of how, as the name implies, you can query the OS and pretty much anything on that OS through OS Query and through kind of a command line. It does scale out, and so you can scale out to multiple different machines throughout your entire environment. You do need to use another application called Fleet to actually manage the configurations on those OS Query throughout your environment. But in general, it works on Windows, Linux, Mac systems, and really just about any system within your environment. And the one thing that is nice about it that just right off the shelf, they do provide various like service packs. And so if I want to monitor the hardware and make sure that the CPU is working correctly, or that it's not overloading or anything like that, we can actually set up monitors on the actual endpoint and forward that off to a SIM like ELK. And so that's for crypto mining, that would be one big thing. You can create a detection off of that. And then same with incident response, they've built out several different packages that you can use that kind of just have default content, and you can forward off into your SIM as well. And so kind of how it works, it kind of basically on startup and boot up, it starts off the daemon right away, returns any scheduled tasks, and a few of the other different tables it has is you can see all the mounted drives that are on the system. You can see all the users that are on that system. You can see any network processes or network connections. You can see processes in memory, and it kind of builds an in-memory database for the system. And then has it that query D continually runs, it will continually forward off logs to your SIM solution. So a basic overview of it and kind of how it looks. All right, so I set it up on this machine, and there's kind of, so basically, as you can see, it kind of works just like normal SQL statements. And so it literally does build that in-memory database. And any SQL statement that you write, you can toss it into the query D, which basically works on a schedule. And so like if every 60 minutes I want to forward off all the network connections on this specific machine or on all of my machines within my environment, I can forward them off and analyze them later. So, for instance, that, and then, so same with usernames, right? So it kind of shows you directory, shell, username, kind of their UID as well for that specific machine. And then kind of the network connections. So kind of shows you all the basic network connections, whatever's connecting to this machine, and kind of builds that table for you. So, in general. And then onto Moloch. So Moloch is a deep packet analysis tool. So it does record full PCAPs as well as NetFlow data, and it records them all into Elasticsearch as their backend, so seeing a theme. And the cool thing about Moloch is that you can actually see, if you open up Wireshark, right, you can see the, like a TCP stream. You can see all the different packets going in and out. And so you can actually do that in the Moloch interface, kind of at scale with multiple different packet captures. So it's kind of really easy to use, and I've used it multiple times when I've just had a PCAP laying around or a part of an incident. Upload it to here, it'll index it. So another part of that, right? You don't need to set this up at scale either. If you want, you can just set this up in a VM lab, and then you kind of just upload PCAPs to it, and you can analyze them there or in here. So kind of some of the key features, large PCAP files it can analyze, stores PCAP and session data, and it can scale out. So if you do want to deploy this, it can handle it. You just need to make sure that you have the proper hardware set up for it, and that it can actually handle this level of data. And then it also visually graphs the network as well. So if I'm looking for or I've got a specific IOC that all my machines are calling out to, it will actually build a graph around that, and I can actually start to focus that visually, which I actually do like sometimes. And then you can also, so it is open source, right? So it does have its own API, so you can connect to the API and you can add a lot of, integrate it into your current environment, do a lot of stuff there. So kind of a quick overview of that as well. So here's Moloch. And so this is kind of the session information, right? So basic NetFlow data in general, right? It stores all this in Elasticsearch. Source IP, bytes in, out. And it does use the BPF, like the Berkeley packet filtering. And you can search by just about any of those values there. So kind of what I was talking about in terms of like TCP stream. If I went into one of these, right, if it works, it's not sliding. Well, looks, there it goes. Right, so, right, it'll show you a bunch of the metadata around it. It'll do ARIN lookups for you, or you can configure it to do ARIN lookup for you. Show you kind of in general high-level stats on the TCP flags. HTTP requests, all that stuff, but this is kind of what I'm talking about, the TCP stream, right? And then this is HTTPS, so it is encrypted, but you want to set up a bump server and then actually decrypt it, so that in here you can actually see the actual contents of the packets as they go across the network. You can do that too, though check with legal before you do that. And then, so SPI view, it kind of is just a general overview of everything, right? So if I took this off, it'll show me kind of just in general everything that it's seen for the last month, right? So certs, it'll show me all the certs in the network traffic that it's seen, all the MAC addresses, all the domains, kind of just a general overview of everything in there. And then you can actually click on these, and you can actually search by them as you kind of go through them, right? So that's nice just to kind of go through. And then this is just a general, bytes and out. And then, so this is kind of what I was talking about with the graph. right, I can kind of focus in on one of these, like, so if this one was actually, you know, I had multiple machines connecting out to this, I can focus in on that and actually filter on that, if it wants to filter on that. But yeah, so kind of a general overview of it. And then it does store PCAP files in there as well.
And the connections, does it show port as well, or is it just IP to IP?
Yes, so it does show port as well. So
And the visual?
in the visual, sorry, let me go back. So if you click on one, right, if it works. So yeah, I do not think it does show the port numbers. But you can still search on the ports. So if you wanted to, I mean, it won't visually, well actually, if you look at the IP addresses,
It's data service.
yeah, it does show it at the end of it.
Got it.
So,
Thank you.
yep. And so then for files, so I only really ran this for a small amount of time because I'm running this on a VM. But, right, so here are the PCAPs, right, that are there, and you can kind of search by them, by their name or by their date, depending on how you rotate the files. And then you can kind of download these and analyze them outside of it with Wireshark if you want to, or within Moloch as well. So that's kind of just a general overview of Moloch.
Just curious, does everyone here have visibility into their network, or are you guys running into issues like this? Because this is an easy way, this is an easy win to kind of deploy these type of sensors, because it could be definitely be clustered. You could definitely deploy these type of sensors to your network and gain that network visibility if you don't have that today.
Yeah. And so kind of the last thing, Jupyter Hub, who here has heard of Jupyter Hub? A few? Okay, so pretty much it's a data analysis tool. And so a lot of things we do in security, or it has analysts anyways, is just kind of analyze data, right? So, you know, it uses a programming language, like kind of whatever you want. It can use R, Python, Python 3, kind of whatever your go-to is, right? For the most part. And you can actually do data analysis on the data within Jupyter Hub. So I'll bring it up here shortly, but, and then, you know, anything you can do, like, so I use Python, so anything you can do in Python, you can use in Jupyter for the most part. And so, right, you can easily write a connector to your Elasticsearch instance or to your SIM solution, depending on if they have an API for that, right? And then you can kind of query it for the same way that you would query Kibana. You can put your queries in there and pull back that information, and then do a lot of your transformation of the data and your analysis outside of it, right? So that is, I prefer it that way also because it just gives you more options in terms of what you can actually do. For a quick search, yeah, I would rather do it in the actual SIM itself in Kibana if I'm just looking for to initially scope it out. But if I'm trying to do deeper dive analysis, using something like Jupyter Lab, where something like this, right, where you can actually write an instant report with it as well. So, and the other key part of this is that, you kind of mentioned before, as you kind of pivot through, and you know you're doing an investigation, you kind of get in the zone, and you do like 10 pivots, and now you're like, I've either got 20 tabs open, or I don't even remember my last queries, and I've got to re-query all the data. So I don't know if anyone's ever run on that. I know I have. So this kind of like saves your query. So this is kind of basic template of how you could write out an incident, because it also takes HTML Markdown, and so you could just edit it in there. Basic summary, and then my connectors, so my Moloch instance to the Elk stack that we have in AWS. And so kind of basically what I did here, any of the data fields that you guys saw in Elk, you can actually query and parse out here, right? So what I'm pulling out here specifically is, you know, first packet time length, source IP, destination IP, total packets, all that stuff. And then I can kind of display it in a simple data frame here. And with these data frames, they've got a lot of, so it's called pandas. So pandas has a lot of built-in features where you can do like, you know, like a unique count, or you can do aggregates, right, with these. And so once I've got this data kind of into the data frame and kind of parsed out, or at least what isn't already parsed out from ingestion, right, into Logstash, you can take here and parse out even further, or, you know, manipulate the data even further. So kind of in general, that's kind of what it looks like for the Moloch data. And so with this, I'm only pulling the actual like NetFlow metadata, I'm not pulling actual any of the PCAP data, but you can obviously query the PCAP data as well. Just have to write in Python. And so kind of like an initial alert, right? So say for whatever reason, this process ID of this machine was flagged and we want to look further into it. And so kind of an initial script on how I would write that out is kind of like this, right? So here's my actual Elasticsearch query, pulls that out, pulls out all the fields of note that I want to look into. And then, the same type of deal, puts it into a data frame. I set the actual index itself so I can sort on date time here as the date time. And then, right, so if I'm looking at the command lines, I can see all this stuff, right? So if anyone's heard of the invoke adversary script, in PowerShell we used it because it's just kind of a simple red team emulator. And so we kind of ran that and it just did a bunch of commands, and as you can see, maliciousness. And so let's say, for instance, I want to pivot off of this and I want to look for PSExec, right? I want to see where else this thing is PSExecing from this machine, or how is it pivoting within our environment. So then I can do a PSExec pivot search. So basically just do a match phrase, which is just match any log that has PSExec in it, right? And so kind of did that search. And so this is also searching system logs as well, because if you PSExec somewhere, you can actually see the PSExec like service being installed on that system, on the target system. So you can kind of see that as well. So did the search, same sort of thing. I sorted it this time though by the index, which is the date time, so sorted by the date. And we kind of start to see a pattern here. So kind of like right here, right, we see Lannister 1, and then if you look at the timestamps, these, this is pretty much the actual command line in the SystemOn logs, where, it does the initial PSExec, and then we see it on the actual target system, right, with services and then PSExec, right? And then as you start to go down, start to see that pattern and build that out, right? PSExec, 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 and kind of everywhere you go. So you can start to build out that timeline, and kind of the best part about this is now I can kind of just save this as a report and share this with either my teammates or anybody else on the team, so that I don't have to send them just a raw query. I can actually format the data and put it into a sensible report. And now I also don't have to go back and rerun all my queries and then pull out the data into Excel file and then format it there. So that's kind of helpful. So then if I wanted to do a process ID pivot search, say I picked out 3 processes that I wanted to look into further, I could put this together. There is a way to search all the process IDs in the same query. I just didn't. I wanted to kind of make it clear of kind of what I was doing. But yeah, so did 3 separate queries, searched for these 3 process IDs, did kind of the same as above, pulled in all that data and kind of tossed into a data frame, and same type of thing. But another thing to add is that there are a lot of visualizations that are built into data frames as well, so, or pandas. So, right, you could easily plot a lot of this stuff into a line graph or into some sort of plot that you wanted to, and kind of present your data that way, because we all know that execs love pictures. So you can easily do that as well. But in general, yeah, that's about it for that. No.
All right, so key takeaways is you guys got to make sure you guys prepare. We all need to make sure we're preparing for an incident, right? Our organization needs to be prepared in case there's a large, medium-sized incident. It doesn't matter, right? We need to make sure we have the right tool sets. So if you guys are not getting the budget you need for a specific tool, whether it's a next-gen EDR or whatever fire EDR tool that's out there, easy way to get it, right? Same thing with the network deep packet inspection tool. If you guys don't have visibility into your network, there's an easy way that you guys can get this and you guys can sell this to executives. The other part too is from a preparational standpoint, right? So we've talked a lot more of the technical side, but I also focus a lot on the people, process, and technology side, right? So we got to make sure, however you decide to go, whether it's commercial or if it's open source, that you have the right people to support that operational model. Most importantly, you also need to make sure that you have the support from the organization to actively respond to an incident. So if I have an incident where, your customer data has now been exfiltrated, how many of you guys have the contact to legal and the privacy person, maybe the GDPR person, to pick up the phone and call them and say, hey, I need some analysis on this type of data. Is this sensitive, blah, 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 right? And then do you guys also have the contacts to make sure that your PR people know exactly what they're gonna say if they get contacted by someone else? So that's just a little bit on kind of the more process side, but those are kind of things that we need to deal with whenever we're managing any type of incident. So just kind of something to keep in the back of your head. And then security visibility doesn't have to be expensive, right? Just because it's a premium product that, it's ranked really high by Gartner, right, for whatever that's worth, then it doesn't mean it's the best product out there, right? Kind of figure out what your organization needs, what are your use cases, what problem are you actually trying to solve, and then figure out whether it's open source or if it's commercial, what tool is going to satisfy those requirements within your organization based on the skill sets you have and your use cases.
And so it also depends on the experience of your own team. So how big is your team, and what is their knowledge base? So if you do have a lot of programmers, you do have a lot of engineers on your team, then going open source might definitely be a way that you could go. Just out of the simple fact that you guys could actually manage it and support it. Whereas a commercial product, right? I mean, you're already going to have that support there. They're going to be able to help you out. But the fact that it's closed source, you don't always get what you want from them. So some of the key takeaways. That's
Yeah,
about it.
and then, well, just the last thing, the Jupyter Notebook. So for us, what's cool about Jupyter Notebooks, I think should resonate with everyone here that's done IR, is you can keep an actual running log, right? You're not having to copy and paste into like Notepad or Notepad++, right? You can start having your queries. It's very visually pleasing and understanding and easy to understand. And you can start writing your notes of what exactly you're seeing, right? And then there's that methodology in place that you can go back and say, this is exactly how I got from a 4624 logon type 10 to now a PS exec to 10 different machines, and then now to showing you that now we have evidence of data exfiltration. So you can have that story that you can tell, because too many times, and this has happened to me before, I'm guilty of it, right? I get stuck on the keyboard, do my analysis, and then I come out to my conclusion, but then I have to go back and try to figure out what exactly did I do to come back all the way here. So doing this through Jupyter Notebooks is a pretty cool way of just not running into that issue and saving you guys time in the future. So you guys have any questions?
Yeah, I just started using Jupyter Notebooks, but haven't looked into it myself. How does that work in a team environment? You can't share that, can you?
Yeah, so Jupyter Hub, you can actually,
with the hub?
Yeah, with the hub, you can put on a server. That actually they just released, I think, about a year ago. Multiple
Okay.
users can log onto it, and you can all work off the same.
Excellent, thank you. Yeah.
Any other questions?
Are there any concerns with the visibility of data or chain of custody or things like that with open source as opposed to commercial tools?
So as far as note-taking, running your searches, I haven't run into that issue, and I've worked with law enforcement on several cases. Never ran into an issue with how you run those queries, because essentially what you're doing is you're running those queries against your Elasticsearch or your log aggregator, right? So whether you're doing it through Notepad or however you're recording that information, I've never run into that issue. Any other questions or? Cool, well, we appreciate you guys showing up for the talk.
Thank you.